Okay, good morning once again. How are you?
Yeah, yeah, fine. That's fine.
Please, we are live on YouTube. So I'll share the YouTube link to the group so that those who are what those who are not here can also benefit from the class. It's a retreated movement, right? And we
Yes,
started
sir.
with
Yes, sir.
definition of movements. That's force times perpendicular distance or distance times perpendicular
Yes, sir.
force. Any of them. The end result is that the force and the distance should be perpendicular to each other. What if the force is inclined to the distance or to the line of action? You resolve the force to the perpendicular direction, right? You can use SOHCAHTOA. So this is what we did the last time. I will solve one question. The action. So, a moment, please. I'm trying to share the YouTube link. Okay, someone is joining. Okay, so let me get a question from Akila here and see. No. Okay, so let's start. Let's start. I'm just trying to drop the video link so that I will not forget. So we have an example here. Let me see one of these examples. Let's use this one. I want like a classical example. So now it says a uniform beam. Now in this type of question, you have to know the what. How to draw the diagram. The diagram is very well important. So let's learn how to draw the diagram. It says a uniform beam. Right, a beam can be a what? Oh, Microsoft Word. I did was to be that this thing is not coming. How should I start? A moment, please. I should wait for the this thing to connect. This is the question. A uniform beam MN of weight something. Disable. So try and write this the question example 4. Write it down. And Microsoft Word is giving me issues. It's not even this one. No, the insert is not scam. Let me paste the question here. This is where is it? Yes, a uniform beam MN of weight 20 newtons and the length 60 centimeters is supported at 2 points X and Y, such that MX is 10 and YN is 15. Two forces 10 newtons and 15 newtons are placed at M and N respectively. If the system remains in equilibrium under the action of these forces, calculate the reactions at X and Y. So basically they are telling us that, let me put this one through. Now the uniform beam means that the beam is distributed evenly throughout, right? So it can be like a rule, a meter rule or something. Let me insert a straight line. So this could be it. Let's see, shape outline. Right. So this M and N. Yes, M, the endpoints M or N. Now they say the weight is 20 newtons, meaning the weight is in the middle, right? 20 newtons. I hope you can all see.
Yes, sir.
So learning how to draw the diagram is very important. The reason why the weight has to be in the middle is because it's uniform. So the center of gravity is in the middle, right? It has length 60, so the length is 60. That means the midpoint here will be what? 30, 30, 30. Are we okay? It's supported at 2 points.
Yes, sir.
It's supported at 2 points X and Y, such that M and X is 30. So now if here is 30, you can divide it into 3 so that you get what? 10, 10, 10. Right? So this is one of the supports. Please. This is one of the supports. X. And another one, 15, YN, 15. So from Y to N should be 15. 15 means that you have to divide the 30 into 2. So if you divide it into 2, this becomes your what? Y. Right, so from here to here is 10. Then here to here we got 20. Right here from here to here will be 15. And here to here will be 15. Now, two forces, 10 newtons and 15 newtons, are placed at M and N respectively. Two forces, M and N, are placed there. If the system remains in equilibrium under the action of these forces, calculate the reactions at x and y. So this support will also cause a reaction. Let me use a red line for the reaction. So this reaction 1. Mind you, the reactional force is the force perpendicular to two surfaces in contact, right? Now that's it. Now it says the two forces M and N are placed at M and N respectively. So this is the first force. They are more like weights. And another one here. So this is the one at M is 10 newtons, and the one at N is 15 newtons. Now, up to this level, are we okay? Any questions? Up to this level, are we okay? Any question? Hey, Monkasa. Hey, oh, you are drawing a diagram.
Yes, sir.
So you should continue.
Yes, sir. So please continue.
Very good. Very well. So now, what is our assignment? It says if the system remains in equilibrium, it means if the system is still at rest, meaning when all the forces are not causing the object to move. Right. Let me signify here as the pivot, as the middle. And find the reactions at x and y. So we are going to find the reactions at x and y. So R1 and R2, or you can say reaction at x. You can use reaction x, reaction y. Reaction x, reaction y.
So please, sound is making noise in the meeting. Someone is making sounds in the meeting.
I don't know who the person is. Sarah. Okay, let's continue. So the principle of movement states that one of the principles of movement states that the sum of upward forces is equal to the sum of downward forces. So sum of upward forces equals sum of downward forces. You know that sigma means sum, right? So the upward forces are what? R at x, R sub x plus R sub y should be equal to the downward forces 10 plus 20 plus 15. And this becomes one equation, Rx plus Ry equals 3045. Right. Now the second principle of movement states that
Yes, sir.
sum of clockwise movements equals the sum of anti-clockwise movements. So you have to take one pivot. So taking moments about. Where should we take the moment? Where should we maintain the pivot? Which pivot should we maintain?
So please, can you come again? The line was breaking.
I'm saying that in the principle of moment states that sum of upward forces equals downward forces, right? That's what we've written. So it means all the forces in the y direction, in the positive y direction, are equal to all the forces in the negative y direction. Or basically the forces moving up. When you add all of them together, you get the forces moving down. Now the next thing is taking moments about a point or a pivot. So which pivot should we use as a moment? We can use pivot x. That means we are eliminating y. So we are imagining y is not there. Are you okay?
Yes, sir.
So if y is not there, which forces will become clockwise and which one will become anti-clockwise? So you can see that if this one is not there, right, this force will push this object downwards, and it will be moving like a clock. So you see that if you have a clock has its hand. If the hand starts moving this way, it is clockwise. If it starts moving this way, it is anti-clockwise, right? So this one, if you move it like a clock, or you spin it around, or you turn it, you are moving it in a circular motion. This one will be moving in this direction. Do you understand? If you are focusing on this one,
Yes, sir.
the same thing, this one also move in this direction, clockwise. Are you okay?
Yes.
So in this case, our clockwise movements will be what? So sum of clockwise movements equals sum of anti-clock. So what are the clockwise movements? Taking about x. So x becomes the pivot. We move like this to the force. Force times perpendicular distance. Right? So the first force is 20 newtons. What's the distance between the 20 and the x? The distance between 20 and x is 20 meters. Or 20 centimeters. Right? Plus, do we have another one? Yes, we do. Which is what? 15 newtons. So now what the distance between the 15 and the x is 20 plus 15 plus 15. Just what? 30 plus 20, 50. At this level, do we understand? Any question at this level?
Sir, please, can you come again with the other side, with the 50 portion?
Yes. We are looking for the clockwise movement. So we found that this force, the 20 newtons, will move in the clockwise direction, same as the 15 newtons. So we are now looking for the distance. The distance between the 20 newtons and the x pivot. So the distance starts from here, from this to this is 20 newtons. So before you start this one, you have to make sure that you've completed all the distances in the diagram, right? Now from 15 newtons, this is 15 newtons. The distance from 15 newtons to x is 15 plus 15 plus 20, which is giving you